If the three least squares assumption hold, and if the regression errors are homoscedastic, then as a result of the Gauss-Markov theorem, the ordinary least squares estimator is the best linear unbiased estimator. Number 5. If the three least squares assumptions hold, if the regression errors are homoscedastic, and if the regression errors are normally distributed, then the ordinary least squares t-statistic computed using homoscedasticity only standard errors has a student t-distribution when the null hypothesis is true. The difference between the student t-distribution and the normal distribution is negligible if the sample size is moderate or large. Key terms: null hypothesis, two-sided alternative hypothesis, standard error, beta hat sub 1, t-statistic, p-value, confidence interval for beta sub 1, confidence level, indicator variable, W variable, coefficient multiplying, big D sub I, coefficient on big D sub I, homoscedasticity and heteroscedasticity. Homoscedasticity only standard error, heteroscedasticity robust standard error, Gauss-Markov theorem, best linear unbiased estimator, blue, weighted least squares, WLS, homoscedastic, normal, regression assumptions, Gauss-Markov conditions. Review the concepts. Chapter 5, outline the procedures for computing the p-value of a two-sided hypothesis test. A two-sided test of H sub naught is mu sub big Y equals 0 using independently and identically distributed set of observations, big Y sub I equals 1 through n. Outline the procedures for computing the p-value of a two-sided test of big H sub naught, a null hypothesis that beta sub 1 equals 0 in a regression model using an independently and identically distributed set of observations. Open big Y sub I and big X sub I, close I equals 1 through n. Review 5.2. Explain how you could use... I need to do the answer for number 1. 5.1, the p-value for a two-sided test, null hypothesis, big H sub naught, that mu sub big Y equals 0 using an independently and identically distributed set of observations, big Y sub I equals 1 through n, can be constructed in 3 steps. Number 1, compute the sample mean and the standard error of big Y. Number 2, compute the t-statistic for this sample. T superscript act equals big Y bar over the standard error of big Y bar. Number 3, using the standard normal table, compute the p-value, the probability that the absolute value of big Z is greater than the absolute value of T superscript act equals